Oh, what a long day. Let's unwind with a little programming. Yes, so here was the problem. You were designing a path object where you can add a whole bunch of points, and not point objects, but pairs of XY coordinates. And then you have a method which will let you calculate the length of the entire path. And if your path consists of a whole bunch of straight lines that connect various points, then the length of the whole path is the sum of all of those straight line distances, the sum of all of those segments. So let's go ahead and start creating objects. Oops. Come on, computer. Okay, so I do not, in fact, want to import something called path. I want to create my own path. Is this an option for me, please? No, it's going wrong already. Okay, fine. So let's create path. And we'll come back to this in a minute and figure out what needs to be in there. Add point is definitely a method. So I hit Alt-Enter and I can say create method add point. And here it is in path. Let's please not use these terrible names. Let's rename the parameters to be something sensible like XY. And again, like let's not fill this in yet. And then the last method that we need is this getLength method. So let's go ahead and do that. All right. Oh, except getLength isn't going to return a string. It's going to return a double. So beware. The auto generation is not magic. You actually still have to think about what you're doing. All right. So path. So if I was going to add several points to a path, one thing I could do would be something like this. I could say array list and then double. So I could have two array lists, one that was a bunch of x's, which I'll call x list, and one that was a bunch of y's, which I'll call y list. So let's pretend, well, let's not pretend, let's actually make a constructor. So I'm going to auto generate that using these two, actually not using those two. So here's path. So I could say x list equals new array list, whatever. Then y list equals new array list, whatever. So when I need to add a point, I could do something like this. I could say x list, add the x coordinate, y list, add the y coordinate. There's nothing wrong with this necessarily. Well, something seems to be wrong with this. Well, that's fine. So there's nothing wrong with this necessarily. You would think about these two lists as being coordinated. So the two numbers in index 0 would be the xy coordinates of a single point, and then the two numbers in index 1 would be the xy coordinates of the next point. However, this is a little less nice than using objects. So rather than have two separate array lists that need to be coordinated, I'll have one array list consisting of point objects, and I'll call that points. I'm going to try and call that points. Here we go. And then I'll initialize it in the constructor, same way that I would in any other context. Let's create the point class. What's just happened? I'm always trying to import stuff that I don't actually want to import. Okay, let's create it by hand. So I'll create a point class. And I know that my point class should have an x and a y. What else it might need later on, I don't know. But let's go ahead and make a constructor. And so I'll generate a constructor using those two. And let's also go ahead and do getter and setter methods. Do I want both getters and setters? Yeah, probably. I think that's fine. All right, so I've generated getters and setters. So there's my point class. And then when I add a point, I can't do something like this. I can't say points.add x comma y because the add method is the method for the array list. And the array list is expecting a single thing that it can hold, a point object. So what I have to do is I have to take this xy and I actually have to build a new point object consisting of those xy coordinates. So you might notice that I've made my point objects able to hold doubles, but then over here, add point is only taking ints. It's up to you if you want to make these double. I'm going to make them int because I'm going to have this I want to use this for a graphical system where these are coordinates on a screen, and you can only have integer coordinates. You know what? Forget it. I'm going to make them doubles. All right. So what now? Get length. All right, so here we go. So I think what I want to do is I want to loop over all the points in my list. So this is very similar to all of the other looping over everything patterns that you've seen so far. So like when we were looping over all of the letters in a string, we'd have like message.length. In an array, you'd have array.length. Here we have points.length, except when it's an array list, it's not called length, it's called size. That's how you get the total number of elements. I want to calculate the distance between each pair of points. So I'll call that dist, and then, or let's call it distance. And then I need like 0.1 and 0.2, but like where are those going to come from? I've got to get them out of the list. So let's call 0.1 points dot get I. So that's the point at location I. And then points dot get I plus 1. So now I've got the point at location I and the point that's directly after that in the list. The problem with this is it's going to go out of bounds because I is going to go all the way to the last valid location in the list. And when I is the last valid location in the list, I plus 1 is going to be off the list. It's going to be out of bounds. So to fix this problem, I'm going to not go all the way to the end of the list. I'm going to stop one before the end of the list. So that way, I is going to be the second to last element, and then I plus 1 can be the last element. So one way of organizing this, well, I guess let's do this first and then we'll refactor. So I'm going to create the distance method right here. And the distance formula, as you recall, is you take the difference in x's, like this, and the difference in y's, and then you return the square root of each of those squared. So square root of dx times dx plus dy times dy. Okay, so that's a good distance formula. Is this the best place to put it? I think maybe not, because if we're calculating the distance between points, that seems like a thing that it would be nice for a point object to know how to do. So I'm actually going to refactor this right away. I'm going to cut this, and I'm going to put it directly in the point class itself. And in that case, we don't need 2 points as an input. We would just have 1 point called other. And then one of the 2 points is the current object that's running, which I'll call this. That's a keyword that refers to the currently executing object. So whichever point object is running the distance method will get that point's x, y, and will subtract the other points x and y. So it's the same equation. It's just that it's a different part of the code that's running the method. And because it's a point object that's running the method, now the point object knows its own coordinates. So that's why we're getting the xy coordinates in a different way. All right, and so now we wouldn't run it this way anymore. We'd say point1 dot, what did I call it? Oh, is it private? Yeah. Let's make it public so that we can run it. So point1 dot distance point2. All right, great. But of course, the point of this is that I want to be adding up all of those straight line distances. So I'll have total sum equals 0, and then I'll have total sum plus equals dist. And actually, if I'm going to do that, there's actually no point in having a dist in the first place. I could just say total sum plus equals, and then calculate the distance there. So to me, this feels very kind of concise and direct and clean. And then at the end, we'll return, the total sum. All right, so let's go back to main and run it. Let's think about what we believe this should be. So I'm going from 0, 0 to 0, 10. So that's going straight up 10 units. Then I go to the right by 10 units. Then I go down by 10 units. Then I go left by 10 units. So I believe the total length of the path should be 40. And let's see if it is. I have run the wrong thing. Let's try it again. Great. Length of path is 40. So it looks like the last two methods we need to implement are the size method and the getPoint method. Size is just going to return the total number of points that have been added to the path. So that should be the same as the size of the array list. GetPoint is sort of like the get method for an array list. We're given an index I as an input, and we're going to either return the point object from our internal list that's at location I, or if I is out of bounds, then we'll return null. Rather than have it crash, which is what would ordinarily happen if you try to access an index that's out of bounds in an array list. Okay, so here we go. Let's do size first. So let's see, public int size, and then we're just going to return the size of the array list itself. Let's make this a little bit bigger. Once we've done this, this is a relatively minor point, but generally once your object has a getter method, it's considered good practice to use the getter method instead of actually accessing your instance variables here, your fields. The reason why is if you access your fields in the minimum number of places, that means very few of your methods actually depend on that variable directly. So that means that you're free to change how you're implementing that variable if you want to. We could change this array list to something else, and if only one place in the code is referencing that variable, we'd only have to change one thing. But if we're constantly running points.size everywhere, then we'd have to change a lot of things if we were going to change this. So this is part of writing code that has minimum dependencies on other parts of the code. Each part wants to be as separate as possible because that makes things easy to change when they're less dependent on each other. So that's, there's no reason why you should have known that in advance, but I'm telling you to you right now, and that's going to be a major theme later on this year as well. Okay, let's go ahead and write the last method. It's called getPoint, and it's given an index I. So there's a couple ways we could write this. First, you could check for your index being out of bounds at the beginning with an if statement. So I could say if I is less than 0, then I know it's out of bounds, so I'll return null. Or if I is greater than or equal to the size of my list, then it's out of bounds, so I'll return null. Otherwise, I'll return points.getI. So this will work, or rather this will almost work. Is this true? Yeah, so what I was thinking about was, would this still work if the size of the points list was 0? And I think the answer is yes, because this if statement would be true no matter what the I value was if the size of the list was 0, and we'd return null as we were supposed to. Okay, great. So that's one way to do it. A different way to do it would be to use a try-catch block. You're not allowed to use these on the AP test, so make sure you know how to do this kind of like input validation in other ways. But the try block means we're going to try and run this code, and if it runs, great. If it doesn't run, we're going to catch whatever error is going to happen. Whatever exception gets thrown, we're going to catch. And all the information about the error is going to get loaded into a special variable, which we're naming E, and whose data type is exception. But actually, I don't care what type of error it was. I'm just going to return null no matter what. So now, if we get an index out of bounds exception because I was out of bounds, instead of it crashing, it'll jump into the catch block and it will run this code, which will return null the way that it's supposed to. So either of those approaches would be great. Okay, I think I'm going to freely play with this now. I'll implement the bonus problem number, I think it was 5 or maybe 6. And then I'd like to put this in a graphical setting to do some interesting stuff with it. So come back if you want to see more.